Where were we?
We were at the requirement of adding Python 3.10 to RPM because of Py module from, no, type from module, module from type and spec. Because of creating the link between type and the module so that we can actually access the module state through the types. Which commit was that? I do not remember.
So we have adding mod state declarations to individual files, making a to-do list. I see I didn't push it. So this one is in my repo. And now we need to bump the minimum version to 3.10. Do you understand why that is?
Yes, I do understand why that is. This is because of a function that is in the next commit.
Right. So let me cherry pick that.
It will not apply because we have custom changes to find package. I believe. We have limited it from the upper side.
Okay. Where do we have that? Somewhere. Oh, this temporary one, huh?
Yeah.
Okay, so that means I will need to rebase and cherry pick this one on top. So just, where do I rebase though? Oh, I don't think I've pulled since then, so I will rebase interactively on so-called master and remove this temporary commit. Then cherry pick that one and then cherry pick the change. Oh, no. That's this one. Could not apply. Great. Could not apply in CMake lists. Main CMake lists. Because we want to limit this so that it doesn't pick up 314. Right? Is that the only change? Yeah. Not used to working in a subdirectory. Okay, so this should work now. Since I did rebase, maybe I want to pull the latest upstream.
Probably collapse a bit because of the changes in the testing functions.
Oh, but we need to do this anyway, right?
Yes.
So
Sooner or later.
In tests local at, and the change is this was removed entirely. Yep, there's no myprint in RPM anymore. Good.
Yeah.
Good. Thank you for that. And if I make check, oh, is there a new build requirement? scdoc?
I haven't seen that one.
What is scdoc? Jail, okay. What? What? CMake lists online 314. What a number. Find program scdoc named scdoc required. Oh, there's a package called scdoc. It's probably in the rawhide build requires, I guess. Hopefully.
Convert many pages to specialist tooling, scdoc. Okay, this was added 3 weeks ago.
And everything passes except for the one that didn't. So I will push that into my branch. Sorry for rebasing. And we can continue.
All right.
So what is next in this little quest? Associate the module with the types. So yeah, so this is adding, so this is using the PyType from module and spec function, which then enables the PyType get module function. Like this one, we can get the module object from the type, which will be important later. Okay, so cherry pick that. And next up is adding accessors for the module state. And this one will be tricky. Let's first look at one of the other ones. So get the state in header py.c. So this is how removing access to the global module state will look. Right? So there's a function header as bytes, and maybe I can. So first of all, we remove this this global, right? I will do that so we see the error. Where is this? Oh, it's in the C file. Right? C file. Go. Make check. And the error is mod state undeclared. Right? So this calls for PyRPM error, HDR type error, HDR type, and so on. So on each of these lines we need to do something to get the mod state, but instead of the global we're getting the specific mod state for one of several possible module objects. So what this will do is basically look at what we have available as the input to this function. So there's HDR as bytes. Let's see where that is used. And HDR unload, HDR reduce. So it's like an internal helper. And it's used in reduce, which is Python method. It's used in HDR unload, which is a Python method. It's used in that's it. Okay. And all of those have an HDR object as argument, so that's what we have to work with. Well, that's one possibility. The other possibility would be changing these functions and telling Python to call them in a different way. So HDR reduce and unload are no argument methods, right? Which means when this Python method is called, Python will call this C function with two arguments. One is the self, the associated object of this of which this is a method, and another is unused. Okay, and this was actually PyObject as well, right? Now, because this is C, well, because this is Linux, this is actually undefined behavior in the C standard, but with GCC and on Linux it works, so that if CPython calls a function with two PyObject arguments, but it's actually a function taking one HDR object argument, it'll just work.
Okay.
Interestingly, there's a build bot, so just for interest, there's a unstable build bot called UBSAN somewhere here. Oh, USAN, which builds CPython with the undefined behavior detection. So there's a flag somewhere in configure that tells, I think it's CLang or GCC maybe, to detect undefined behavior. And Python, the test suite doesn't even get to the first test. And it's exactly because there was a call to some function through a pointer to incorrect function type. And that is exactly what RPM is doing all over the place, and all the other Python extension modules are doing as well. And it's working, and the C compiler authors are free to change that and make it blow up on everybody. But they probably won't, because they would break everything. This was a problem when porting to one of the early JavaScript runtimes, which actually made this undefined behavior. So yeah, it's a bit of a problem, but we're not here to fix that specifically, right? A meth noargs method takes self with any pointer type you want. It's actually if it's a Python object, right? To make this easier, if we were going for top performance, instead of meth noargs, we could tell Python to call this with a different set of arguments, right? So this tells Python what to use, and there are several calling conventions, a lot of calling conventions. So the simplest one is noargs. There's an unused argument. The second simplest is meth-o, which where it takes one Python object as an argument. Right, so like hash or math.sign or something like that would take one argument.
I'm puzzled about the naming. I'm really puzzled about the naming. Like meth-o will take one argument, meth-noargs under the hood requires two parameters. It's just...
So yeah, this is almost 30 years old now, you know. It made sense back in the day to someone. Some time later in Python 1, or maybe Python 2, functions could take a variable number of arguments, like more than one. It's probably Python 1. So that's meth-var-args, where it takes a tuple of arguments. There's meth-keywords, where it takes dict of keyword arguments. That was also added later. You can combine those two flags, and I think some of this does that, yeah, args and keywords. There's a fast call that instead of a tuple takes a C array of Python objects directly. So if you're going for performance, and then you can switch to that. That can be combined with keywords to also take keywords argument as a dict. There is method, which also gives you the defining class as an argument. And what that is a bit unclear, but that happens to be exactly the thing we would need. But I'll go through the rest. So there's meth class, which makes this a class method. So instead of self as an object, it gets the class. There's static, which will be passed null instead of the self. And then there's coexist, which is not important right now. So back to the defining class. The problem with getting the module state is in subclasses, right? So we're getting the module through the type. So we're getting the module that defined the type, right? If all we have is self, this one, and it's a subclass of this header object defined in some other module, then the type of this object will have a different module associated with it, right? So what do? We look at all the superclasses of self's type, walk through one by one until we find one with the right module in it, and use that. For that, we can use PyType getModuleByDef, where we give Python some identification of the module object we want, which needs to be static and global. It's like a marker to tell us, this is the module we want. Any module instance that has this marker is the one we want to use, right? And that is the PyModuleDef, which we encountered earlier. It's somewhere here. This one, right? So the definition of the module is static and global, so that'll be our marker. That's what we'll look for in the list of superclasses. Right? Now, walking the list of superclasses is slow for some use cases. I don't think it's too slow for RPM. RPM Python bindings are not the fastest in the world, and that's fine. So we can just, and also, I mean, who would subclass an RPM header object? You can do that, but is it important to optimize that? No. Will somebody make a chain of 100 subclasses for that so it starts making sense to optimize the walk? Probably not. Right, so we'll not do that. But if we wanted this to be as fast as possible, we could use this math method where Python will give us the defining class. So that's the class that this method was defined on. And that one needs to have the correct module, right? So it's quite complicated. It needs to be used with math fast call and math keywords, and not, for example, math O, because someone was lazy back then. Hello. And so it only so the signature, instead of like one argument, takes the self, the defining class, the C array of positional arguments, the number of the positional arguments, and a dict of keyword arguments. Right? Now you can see why I was lazy and didn't define variants of this with, this one missing and that one missing. Yeah, there's just one, and you and you would need to use that. But again, I don't think it's necessary in this case, so we can use PyType getModuleByDef.
Can we? Part of the stable ABI since version 3.13.
Ah, right. Yes.
Small issue there.
Yeah, there's a small issue there. This function actually internally only uses stable ABI for 3.10. So what we can do is yank it from CPython and put it in RPM. You normally have to honor the license, but I wrote that and I'm licensing it to RPM. So it's fine. And I think the pull request actually does that. So we can use this. We can use it with a def, and that's what we'll be using. You can use PyType getModule for classes that cannot be subclassed. And let's see this header object. How can you tell if something can be subclassed? It has this base type flag. So there's a special flag that enables subclassing, which sounds weird because in Python you can subclass most things, but if you do like this, bool is not an acceptable base type, that means this flag is missing.
Okay.
If we have the flag, we need to use the get module by def. And I think that's most of these, so we'll just use it every time. This does walk the list of superclasses, but if you can subclass, the first one will be the correct one, so it'll just have an extra check. So not that hard. So what we will do is define a few helpers. RPM module state from object. We'll take an object, get its type, get the module from that type, and get the state from that module. So there it is for headers bytes. There it is for header format, which also needs the mod state. Next up is HDR new. That's a function that creates creates the self, so it doesn't have the object yet, it only has the type. So for that we will define a new helper called RPM module state from type, which again needs to find the correct type with the correct module and get the module state from that. There's a from object again. And I see there's an HDR get tag function that I guess is internal, and it gets a mod state argument. So that's an alternative if like if the function is internal and we can change its signature, we can just pass the module state to it instead of getting it inside there. Version compare. Yeah, I renamed this argument here because the first argument is not the header object or the version object, but it's the module. So version compare, let's look at how that's defined or where it's used. Oh, where is this used? Not in this file. Oh, an RPM module. This is added as a function of the RPM module itself. And functions are methods of the module. Or at least the C signature looks like that, right? So the self here will give you the module object, which is great because the module object is what we want. So we have the module ready. So there's another helper module state from module. And I think that's all of it. So 3 helpers from object, from type, and from module. And with that, it should be all. Oh, there's one more thing. There's header object check, which checks if a particular Python object is this header object. So here we can't be sure that it actually has the correct module. So we do module state from object, and if the module state is not found, we know it's not the correct object. So we return false, otherwise we compare the type. And since this can be subclass, that's not actually the correct check, but we're not here to fix that. So if you compare the type of an object, you will miss subclasses, of course. Oh, there's so much that could be improved in this. All right, so let's look at the helpers now. They're added to rpm module.c. Maybe they're defined in the header file and added to rpm module.c. I'll cherry pick this now and look at it in the editor. Is that here? What's the name? Okay, so rpm mod state from module. There's an assert. I think we talked about asserts, right?
Not sure right now, but
okay. Assert makes sure this condition is true, but only in debug builds.
Oh yes, now I remember.
Okay, so we assert that the def is actually correct. You're getting the correct module object, or at least so what we're asserting here, that the module state has the correct memory layout, right? Because the module def is the thing that says that defines the memory layout. It includes the size, and it basically everything with the same def will have the same memory layout. So we can then use members of the state. We can cast the state to our structure that's defined here, right? So that's what we are ensuring here. We use PyModule getState. If the state is not found, then we raise an exception. Unless an exception was already raised. And we return the state. So this one is easy. Then there's PyType getModule by def, renamed as MyType getModule by def. And this is basically taken from Python 3.11. It was optimized in later versions, but I'm not the author of that code, so let's go with this one. So it needs to work with a type. It gets its module. If that module has the correct def, we return it. So this is the fast path. If there are no subclasses involved, we just return it. Otherwise, there's some error handling. We call MRO on the type to get the list of superclasses. Normally there's internal Python API that will do this, but in the limited API we can do that. We get the size and we walk the list, right? Starting at 1 because we already checked position 0. We get the item, check it. If it's right, we return it. If some error handling, and if we don't find anything, we set an error. Let's see how this is actually defined in NewPython while we're here. So that would be in objects, type object probably. Oh, it's a bit different. It reaches into the internal structures directly, so it checks a flag to see if this type, like if the internal structure can even have a module def attached. If not, it returns null. This here is the fast path. If the types module has the correct def, we return that module directly. Then there's some locking for the free-threaded build. We look up the MRO instead of calling a Python method, which of course is faster. This is probably just where's this defined here? This just gets doesn't assert and gets a member, and that'll give us a tuple. Where was that here? That'll give us a tuple. We assert a bunch of stuff, like we're getting a non-empty tuple, and the first item of the tuple is the type itself. And then we walk the tuple, check if this can have a module def, so that we can reach directly into the module with this underscored fast function, and return. If we don't find anything, there's an error, right? So it's basically the same thing, but it's using internal API and it's a bit faster. But again, for RPM, this level of speed doesn't really matter. So we re-implement that, and now RPM module state from type just calls that, and then gets the state from the module, and from object gets the type and calls that on the type. So if we could use the 313 or whatever API, this would be 3 very simple functions. Since we can't, it's a bit more complicated, and it has the additional little problem that if you have a if you have a subclass of an RPM type with a custom meta class, or a type attribute called MRO, basically if you override the standard MRO method, this will probably fail in weird ways, so don't do that.
Okay.
And yeah, we can remove that later sometime. If somebody actually finds this bug, it'll be in 5 years. So all right, so does that make sense?
Yeah, on the overview level, yeah.
Okay. So then we get the state in header py.c. We already looked at the use. Oh no, I have local changes. Right, next one is remove the to-do when it's not needed. So this line was added to all the C files, and in some of them it's not actually used. So that's easy. And then we just need to go through all the C files and use the 3 little helpers, and I don't think we're doing anything else in here. From object, from object, from object, from object. What's this? Header py.s. Okay, so this is doing something interesting. What is this doing? should we retrace the steps that go toward this? There's rpmfd.py. Oh, right, and this is this file that we want to fix. Defines a function rpmfd from PyObject, and I guess that's gets some arbitrary Python object and needs to wrap it in an rpmfd and set this, like, see the 2 stars here? That's a pointer that needs to be filled with a new rpmfd object. So we don't have any connection to our module in here. Right, so what this does is it adds a mod state argument, and then it uses that to uses that for rpmfd object check. But that's not necessary, is it? Like if we do
Removed
this
all of
change,
it.
then we don't need the module state here. Okay, so let's do this manually. This could probably be simpler. So rpmfd py.c. So removing this is the goal. The error is in rpmfd object check, which is defined to this equality, and it appears 3 times. So we go here to the header and define rpmfd object check in a different way, and I think I'll just copy that one. GitHub is getting its super cool new interface, and it's breaking stuff like copying from it. Okay, rpmfd object check, so it gets the module state from the object. If it didn't find the module object, it'll clear any error it gets and return 0. Otherwise, it does the same thing as before because it has the module object. Let's see if that works. Oh no, I missed one. Okay. Yeah, I see. Okay, so it's not just for this check, it's also for this, which wasn't visible in the diff, because this mod state was a global before. Now we need to get it as now we need to get it somehow. So this was actually necessary. This function needs to take a new argument. That means its definition in the header needs to change. And everything in the whole project that calls this function needs to give it a module state.
Mm-hmm.
So this is a long pull request. I think it also targets RPM files py.c. So it should remove the mod state, and then it needs to get the mod state in various ways. There's an RPM file wrap function.
Mm-hmm.
Wrap, I think we saw a wrap function before. So this will take
Sorry.
the wrap function will take an internal RPM object and wrap it in a Python object.
Mm-hmm.
To do that, it needs the type of the Python object, and for that it needs the state, which it can't really get from anywhere. It can get from its arguments. So all the wrap functions will need to start taking module state as well. So here it is. Wrap gets a module state. Nothing else is in this diff because it was previously a global. Now there's RPM files get item, which can get the module state and will pass it on. There's some other function that will take get the module state, pass it on. There's some other function that will take the module state, and what happens here? Okay, so this is interesting. So there's that function called pyarg parse tuple and keywords. Have you seen that before?
No, I haven't.
Okay, so here's some interesting Python API. Are you still taking this in, or is it too much information?
I'm trying.
Probably need to slow down. So parse tuple and keywords is a function that will take a tuple of arguments and a dictionary of keyword arguments. Right? So this is looks like a method that takes a self and arguments and keywords. Parse tuple and keywords lets you write this kind of description of what the arguments look like, and it'll take an array of the keyword argument names, and it will take addresses where to store the result. Alright, so let's see. Takes arguments and keyword arguments, takes a format, takes the array of the names of the keyword arguments, and then extra positional arguments, which are the addresses where to store things. And the format is defined somewhere here. You can use, this is building, this is parsing arguments, so you can use S to take a string and convert it to a C string. You can use a zillion different variations on how to build a C string from a Python string, so it's not, or bytes or stuff like that. Still strings. There's a zillion variations of numbers, like you can get a shortened or an unsigned shortened or a float or long and so on, and each one has a letter you can put in the format. There's other objects, so if you do O, you just get a Python object. There's a bool. You can unpack tuples, and also you can, I think this actually uses it, this pipe means The remaining arguments are optional. And what that does is, if the user didn't give us this right argument, then nothing will happen to this address, and the writer will stay at 0. Right, it's not filled in this case.
That's very low level argument like handling.
Yes.
I haven't seen it anywhere. Like I know we are defining when we are defining a module and methods, we like add those keywords. We were looking at them earlier today. But I kind of assumed that there's so much machinery that takes care of parsing everything that is passed to those functions.
Right.
But here, this is like a lot of overhead to that.
Well, you're getting Python objects, and you want an integer. So you can take this tuple, unpack it, take the second thing from that tuple, and call pylong as int or something like that to get the C integer.
Okay.
Right? And of course you need to handle the case where it's passed as a keyword argument, so you also need to look at the dict to see if it has a right entry in it, and then you need to check is it present in both of these, which is a conflict which we need to take care of, raise an error probably. If it's not given, what happens? If it's not an integer, what happens? If it overflows the cint, what happens? Right? Yeah, and all of that is packed into this little pipe I and parse tuple and keywords. So this is pretty high level for C.
Okay.
It's not particularly efficient, but very easy to easy to use. So what else? There's you can mark things keyword only. You can pass a function name to use in error messages. I don't think RPM does that. And you can use a different error message altogether. So probably not that useful. The thing we were looking at here is the converter. So ampersand. Apparently we ran out of letters, so now we need to use two letter combinations. Or maybe it's because it takes two C arguments. So this takes a Python object and passes it through a converter function. And that function can change the object. Well, that function will fill in the address, or it can raise an error. Right? So here it is using rpmfd from PyObject, which is a converter function, and the converter function takes the object and the address to put that object in, right? So far so good, but rpmfd from object needs the module state apparently. So we cannot use it as a converter. A converter only takes these two arguments. So it's broken out here. Instead of the converter, we just take an object, call it FDO source, that's a Python object, and then call rpmfd from PyObject separately to convert the source to this FDO. And that can fail, so that can return a null. Does that make some kind of sense?
Yeah, the converter part with its API and the fact that we cannot use it like that because the function needs small state, that makes sense.
Perfect. I think that'll happen a lot in these commits. Alright, then it's more of the usual. Wrap takes an argument Okay.
So wait a moment. Just like if you scroll just a bit up, this is something like the mod state here, 518, line 518. Like this free for lines of code. It happens a lot also in the previous commits, but it's just like we don't work in any way with this mod state. We just
Oh, yes.
create it within
That's
the function.
because
What else? What now?
previously it was a global variable, remember?
Yes.
We removed this.
Mm-hmm.
So the code after this somewhere uses it. Here.
Oh, okay. Okay. It wasn't visible from the diff. It looked like random four lines of code here and there, but now it makes
Well, but
perfect
here,
sense. We just
right?
need to
It's
create.
it's not in the diff
Yeah.
at all. The code just uses it.
Mhm.
Previously this was a name for a global variable. Now we've made it local.
Makes perfect
But
sense.
it's the same name.
Yeah.
Yeah. Okay, so now I think that should be everything in these. So the check functions get expanded, the wrap gets a module state argument, and all the callers need to be updated. So in RPM TSPy, there's RPM FD from PyObject, the same thing. Previously it was a converter, now it's called separately. There it is again. Previously converter. And if we go from the start, again converter, getting the mod
Ampersand
state,
magic.
passing the mod state. That's just a lot of manual stuff, and I hope nothing changed in RPM. Hopefully this still applies.
If I understood the maintainers of RPM correctly, there is not so many people like actually taking a look at the Python parts of the project.
Yeah, it shows. I mean, if somebody
Yeah.
would pay you to take better care of RPM Python bindings, you could spend a few years on that.
Yeah, I guess I can imagine.
Okay. Next up, RPM keyring.py. This looks simple. So it's more of the same. Remove this and fix the errors. Define mod state here. RPM keyring from object needs to take a mod state. So I guess this was a converter-like function. But it's only used in one place. Where... Oh, this is a file we haven't converted yet, so it just uses the global. Yeah, so this is one of the simpler ones. Next up, RPM macro. So here we get the module. It was called safe. It's the module. So apparently this is a module level function. And this also converts RPM MI, which is pretty simple. You want more commits like that? Oh, did I skip someone? Did I skip some? No. RPM PSPy. There's an RPM PS as list. So this again takes some internal RPM type and needs to wrap it, so it needs a module state. It doesn't have any way to get that. So its signature needs to change. It's in the header as well, and all the callers need to change as well. This looks like files we haven't seen yet. I see there's a typo in the commit message.
So with the files called rpm-ps, rpm-ts, rpm-te, do you know what are those double letter like short?
Let's look at the
things?
doc strings. rpm-ps. No doc string. Oh, but this is rpm-fd.
Okay. That kind of like sends me to the realm of file descriptors, but I have no idea.
Yeah, rpm.fd, probably. Well, it has name, mode, closed, and flags, so it's probably a file descriptor. Why it's... Oh, I'm in rpm-fd.c. rpm-ps, okay. rpm.prob. rpm-prob doc. Ah, here. Aha! Here's the documentation for it. It has attributes type pkgnevr, altnevr, key, stir, and num. So, of course, we all know what never is.
Yeah, like Epoch version release. That's great.
Yes. But what RPM prob is, I have no idea.
IPM problem object I see here in that file, so maybe those are...
No.
I did not want to deter us. I was just really curious whether you've got more intel into what you're like changing to what, based on like what those things are doing.
No, I know nothing about the RPM side of things.
All right.
But there's quite a lot of tests, so hopefully this works. Yeah, but I mean, this is just wrapping some objects in Python in some way. So. I think I applied this one.
Yes, it had the typo, which you corrected.
So RPM strpool. A pool of strings. So what does this do? Again, there's a pull from PyObject converter, and this time it's optional. So it's set to null first, and then checked if it's still null. If it's null here, then this pool will stay at null, and the error will not be, or the pull from PyObject will not be called. Here it looks like it's the same thing. Where does mod state come from? Oh, this is a file we already converted. It used mod state somewhere else. But this function didn't have mod state yet, and it needs it for pull from PyObject. Here, this just needs the mod state. I hope all of the commits are the same now. RPMTE. What that is, I have no idea. Element of a transaction set. Oh, it's quite a lot of documentation. wonder if that's rendered somewhere.
It is. There's more of RPM something. Yeah.
Oh, nice. Okay. Anyway, who cares? We remove the mod state, get it from objects, and that's it.
Mm-hmm.
RPM TS, same thing, same thing. What is this? Oh, okay, let's look at that one. RPM TS.
Okay. I'm not sure if you follow the time, like we are already over
we're
the
already
allocated time box,
past
so just, do you want to finish it today or?
Well, the family is away somewhere, so if you have time, we can continue. But when they come back, I'll need to end rather abruptly. Is that okay?
Yeah, I guess we can continue.
RPM TS. So if I remove this,
things happen.
Things happen. So there's the check, and so on. Let's look back here. I'm looking at RPM TS callback. Alright, so where do we use the mod state? Here. So RPM TS callback gets some kind of argument. This is probably just an integer. And bunch of stuff, and none of that is a Python object.
Mm-hmm.
It's a callback, which means transaction set callback, right? So that probably means when RPM is making a transaction, we register a function to call when the transaction is done or in progress or whatever, right? And RPM will call that C function, and that C function needs to wrap a Python function that gets called as the callback. That's what I imagine this is doing. And usually when you have a C callback, it gets a void pointer as an argument, just with any data you want to pass through.
Mm-hmm.
So that argument needs to be cast to some C type, and hopefully from there somehow we can get some Python object. In this case, so it's not this args, that's callback data, CB info, and that has, I already figured it out before, so that has a TSO, which is a Python object we can use for mod state from object. Well, first we need to check if it's actually a valid Python callback.
Mm-hmm.
Then we can use this. So that's the interesting thing here. family's back, so let's end this and continue next week.
Cool. Looking forward to it.
I think we're what's this RPM TS? We're almost done.
Very close.
So I've pushed it so you can look at it if you have any questions. You can ask next
Yeah.
time.
I'll make sure to review the recording as always and try to comprehend it better.